Hello, and thank you for having me. I'm honored to be here, and I'm grateful for your time and attention today. While this may seem like one, it's not actually a product talk per se. It's more of a peek into the way we approach the challenges of building, operating, and evolving Heroku Postgres as a service, which is to say that I'll walk through what we think makes for a great managed service and show you what you need to do to build one of your own. And before we get too far, I want you to know that I'm going to talk about some things that we've shipped, some things that we're building now, and some things that we're thinking about for tomorrow. And as a result, I must also show this slide and remind you that if you do make any purchasing decisions today from this talk, please do so on currently available product, not my dreams and desires. And quick show of hands if you're still reading this. I can leave this up for another second or two. OK, full disclosure, I allowed some scope creep. The title of my talk is a bit misleading, and for that I apologize. I've let all my better wishes go and all my training as well. The reality is I have 25 things to talk to you about today in 20 minutes or less, but it's not so daunting when I break them out like this. And there's no millions or billions here. I can't top what Microsoft is doing. So let's start with the 7 most magical words. That right there, that's my official title at Heroku. It was on my offer letter. It's on my LinkedIn profile, so you know it's real. It sounds fancy. It looks important, but my colleagues in the audience will tell you the truth. But here's the point. I'm a product manager. I was born to be a product manager, and going way, way back growing up, the knock on me was always that I had my head in the clouds. I was always thinking about what could be. I had little care or concern for what was already done, and solved problems never really interested me. So why am I working on Postgres? Well, 20 years ago, in my very first job, I made an icon with 4 servers floating above a cloud. And when I think about where I began and where I am now, it's clear that I somehow managed to turn having my head in the clouds into a career, which I think is pretty awesome. And I should also say, full disclosure again, I'm not an engineer, so lower your expectations. In fact, I've only mastered 1 SQL query to date, but I'm told it's pretty powerful and returns the entire universe. I got a Postgres joke in. That's awesome. OK, good. I've never actually tried this. See me later if you can help. So let's talk briefly about Heroku. Heroku started in 2007 as one of the first cloud platforms. It was also, and still is, we think, the most developer-friendly one, too. Our founders and first employees were pioneers, and they ran Postgres internally to run Heroku. And in 2011, they brought Heroku Postgres as a service to market. Again, for developers to use. We're 8 years in and still going strong. We also run Heroku Postgres and Apache Kafka on Heroku as a service. And in fact, we're the first to market with Kafka in 2016 as a service, I should say. Salesforce acquired Heroku in 2011, just shy of 8 years ago. And we're a big part of their story, too. We see the world in similar ways, even if we approach it from opposite ends. So with that background in mind, I'd like to move on to the next section. So as a product manager, I've always collected ideas and insights that resonate with me, and I continue to come back to these 3 principles for support and guidance. I was also delighted to find these sort of embedded in the Heroku ethos. So no one has officially sanctioned these as like our own, but I think they're useful for what we're about to discuss. So first up, don't make me think. This principle comes from a book of the same name written by Stephen Krug, I think is how you pronounce his name. If you haven't read it, you should. It's great. But you could probably also guess the thesis and the general gist of the content. And the point is that thinking and doing are friction. And friction, as we know, slows us down. And I found this deceptively simple mantra really helps clarify what's important and optimize what's truly necessary in a product, service, or feature. And knowing that, it doesn't mean dumbing things down. It means reducing the number of steps to take or decisions to be made. It means finding the right abstraction and the most descriptive words to explain it. It's what makes a managed data service useful and usable from day one on. And second, and I love this one, mean time to dopamine. This principle comes from a former colleague and very dear friend, Andrew Clay Schaefer. I have no idea if he coined it or merely found it along his path in life, but I think it's pure genius. And dopamine is actually more complex than the pleasure center we've long thought it to be. It's now understood to be the chemical means of sort of motivating and propelling us to a desired outcome. And it's a slightly subtle but important shift. In many ways, I see it as the corollary to don't make me think. It's the payoff of a well-executed feature, a streamlined workflow, or a seemingly magical product experience. You use it, you see good results, you want to do it again. In the cloud, that means a service that gets you up and running quickly and keeps you going productive forever. And third, undifferentiated heavy lifting. And this principle comes from Andy Jassy of AWS fame and unimaginable fortune. This one is a bit nebulous. To many, it's akin to don't reinvent the wheel. I think it's also about focusing on that which is truly differentiated. Your business logic, your customer experience, your user value, rather than the bespoke configuration of your infrastructure. Maybe it's the opposite of don't make me think or mean time to dopamine, kind of like, I don't know, Kubernetes. If doing something is tedious, time-consuming, and brittle, chances are that's undifferentiated heavy lifting, especially if someone has already turned it into a service that you can use or consume without messing with the details. I like to remind my colleagues and customers that in our business, there are no points for pain. Just because something is hard doesn't make it valuable. And I hope and trust you'll see these themes as relevant as we move forward. And finally, the payoff. So let's talk about those 10 important features for our managed Postgres service. I didn't mention this up front, but my 20 or so colleagues in Heroku data engineering run over 2 million managed data services, most of which are Postgres. We've seen just about everything, including our recent discovery of a 10 terabyte, 10,000 line hobby database. Craig, you'll love that. Please don't do that to us. Point being, we've learned a ton along the way, and we've built so much of that insight into our service. And I recognize that on some level, we all need to, quote, manage the database. Don't take a picture of that, Chris, while I'm doing air quotes. But we at Heroku aspire to make that a rarity, not a necessity. And when you do need to do it, as quick and painless as possible. The goal is to help you put the bulk of your effort into working with data, not managing your database. So here's a look behind the scenes at how that all comes together, and a recipe for how to do it on your own, if you so choose. Okay, so first of all, it's one thing to stand up a Postgres database. I'm sure most of you have mastered that by now. But the reality is that there's no one-size-fits-all configuration. There are different use cases, business requirements, budget concerns, risk profiles, performance tolerances, and infinite permutations, too. You want to solve this problem with a wide range of plans and price points, each with their own set of features and functionality. And whether your service is public for the world or private for your company, you want to address different communities. You want to address learners and tire kickers with free and low-cost plans, emerging businesses with affordable, production-ready plans, scaling and stabilizing businesses with HA plans, enterprise budgets and risk profiles with dedicated network-isolated plans, and even regulated industries with HIPAA and PCI-compliant plans. And of course, these should all come in a range of sizes to satisfy different use cases from dev, test, stage to prod. Oh, and in all regions around the world, too. Easy. Second, you want to make creating and scaling and otherwise interacting with your Postgres service a simple command in your CLI or web UI. It should all be powerful and fast, too. That's obvious. You want a quick and easy way to create read-only followers for horizontal scalability or for external integrations. You want a quick and easy way to clone a database for testing schema migrations or running other experiments. You want to be able to restore a database to a previously known good state. And you want to be able to share data with colleagues or non-technical users without providing access to the underlying database itself. And again, those are table stakes. Third, you want something as important as high availability to be both affordable and effortless. We all know that cloud infrastructure is ephemeral, that things break in strange ways for even stranger reasons every single day. And for a product team to run true production workloads without putting their customer experience at risk, HA is a must. But the complexity of configuring it, sustaining it, and triggering it only when needed, and avoiding false alarms too, is non-trivial to say the least. So you want to build logic that provisions a follower on geographically separate infrastructure, promotes the hot standby when the primary database becomes corrupted or inaccessible, destroys the old primary, and handles the creation of a new follower to replace the old one. And that should all work without human intervention. Fourth, you want to create a way for maintenances to be scheduled and run, along with user-friendly features like notifications or delays, rescheduling, whitelisting for VIPs, and more. Also that your customers have control over their uptime and upgrades. And HA can be particularly thorny here, as you won't want to pull a standby offline for maintenance and leave the primary in limbo. That's particularly bad for keeping your SLAs in order. Basically, you want to minimize downtime. You want to minimize customer impact. And every second counts, so there's no room for manual processes. It's rare, but certainly possible, that you'll need to roll your Postgres services without notifications or niceties, such as when you have a P0 or P1, and when that exploit is so damaging that some unexpected downtime is preferable to the opposite, or to the, sorry, lost that. So make sure you can act quickly, decisively when necessary, and 24 to 48 hours isn't much time to go and do all that work. You also need to apply lower priority patches, updates on a timely basis. And don't forget about version, deprecations, and upgrades, both minor and major, and extensions too. Fifth, you want to provide a batteries included solution for health checks, auto remediation, monitoring, and logging. The health of your managed Postgres services should be constantly monitored, and if any health check fails, you want automated processes to restore your database to a known good state. You want to provide a metrics feed or dashboard for the health and performance of the database and server. You can also surface expensive queries that are slowing performance and impacting your customer experience. Of course, logs are equally important, and you want to make sure that both the database and server logs show in the same feed as your apps. Sixth, you want to have a robust set of roles and granular permissions to govern access and use of your managed Postgres services. A default credential with permissions just below super user can be used to create and control all other credentials. You want those credentials to programmatically propagate across HA standbys, followers, and forks too. You can assign separate table-based credentials to apps, read-only credentials to analysts, and so much more. But remember that you need the full life cycle of creating, attaching, detaching, and deleting credentials. And speaking of life cycle, you also need to consider how to rotate credentials without orphaning apps or users. You could allow for a 30-minute window to ensure in-progress transactions finish, or you could force rotation of credentials immediately, effectively killing all connections and performing the rotation. Seventh, you want to standardize on a disaster recovery story to ensure that your managed Postgres services are continuously protected. Physical backups persist binary copies of database cluster files, known as base backups, and persist write-ahead log files to reliable storage. The physical backups allow you to recover entire databases in the event of hardware failure and data corruption or any large-scale outage. And bad things are bound to happen, and happen when you least expect it, so this is critically important for the viability of your service. And that really covers running the service. Eighth, you're going to want to support an additional method of exporting your data for your users to back up and restore to anything they might want to do, including on a local machine. And logical backups can be captured using pgdump and restored with pgrestore or psql, depending on the format, of course. And I'll betray my limited understanding of the underlying technology here. I suspect some of you probably wrote parts of that code that make that work, so I'll not try to explain that to you. But suffice to say that frequent logical backups can slow things down and even prevent necessary maintenances from running. So this is a perfect use case for a fork or follower to remove that load from your primary database. We're almost there. Ninth, and this comes as the most obvious one yet, you must focus on security. If you're running a multi-tenant Postgres service, you want to make sure the customer data is stored in separate access control databases per application. Also that each database requires a unique username and password that is only valid for the specific database and is unique to that single application. All connections should require SSL encryption to ensure a high level of security and privacy. And you should document best practices too. You need a vulnerability management process to remediate risks with minimal customer interaction and impact. That's really important. This is what makes you secure by default, which means you need a team of experts to triage vulnerabilities as they come in, assess your exposure, determine your response, and bring the right team to bear to work on that project. As mentioned before, you need to be on top of your updates, your security fixes, and software patches. You want to continuously and seamlessly migrate your customers to new instances with the latest software. You also want to place your Postgres and other data services in a unique security group with limited access only to the ports and protocols necessary to work. You, of course, need policies around privacy, customer data access, and employee screening. You need to think about all the underlying dependencies on your infrastructure and other providers, as there may be additional vulnerabilities there. You may also wish to serve HIPAA and PCI compliant workloads, which require strict security, severely limited ingress and egress over trusted connections, and so much more. I could do a whole talk about that subject alone. And even in this extremely high-level overview, there's just so much work to be done. The cost and complexity involved is massive. Last but not least, you need to think about how your Postgres service will interact with the larger ecosystem of apps, clouds, and data services. After all, data is useless if it can't be brought to life in an app or experience or put to use in learning. And typically, you'll have one or more apps that need to connect to that Postgres. And again, you should have unique credentials. They should be rotated frequently and programmatically, too. That's a given. But external integrations are every bit as important. We're now in the age where no single data store is sufficient to cover all workloads and use cases. And there's value in having a wide range of solution components. Analytics, archive, machine learning are all now common use cases, and data should flow freely between them all. Apps run in multiple clouds, but need access to Postgres. Resources are running in private data centers, too. Fact is, Postgres needs to play in this ecosystem to remain as relevant as it is today. And all of this needs to be orchestrated and enforced with security at top of mind. So those 10 features, that's pretty simple, straightforward. But in reality, that's like hundreds and thousands of decisions to be made. I just shouldn't say hundreds of thousands, but hundreds or thousands of decisions to be made. Some large, some small, but all are important to get right. And I think you'll agree that this is a complex effort to do well. And at a certain point, you have to ask yourself if your use case is really all that unique, if your requirements really do mean you should roll your own Postgres services, if you should even be in the business of running a one-off Postgres database. At the end of the day, you want someone or something to do these things so that you can do the things you love, like working with data, making interesting and valuable things with it. And that's really the value of a managed Postgres service. So yes, there are trade-offs. You won't get to tune all the knobs, or you won't get to tweak all the settings. You won't have super user access to everything, but you will have a high performance and cost-effective database that's largely ops and drama-free, and that's no small feat. And if that isn't enough, there's always more features and functionality to add and adopt. And here's a bit more about what I'm hearing from our customers, and I would love to hear what resonates from you as well. Multi-region replication, it's an increasingly hot topic for us. Multi-AZ is great for HA, but what happens when an entire region like US East 1 goes down? As you know, the answer is nothing good. Equally hot is CDC or change data capture. How do you move from a monolithic Postgres database to a distributed event-driven architecture without starting over? Bring your own key. Happen to think it's a bit of fool's gold. After all, the chance you'll catch a breach as it happens and miraculously pull the key just at that moment to thwart an attack, well, that's science fiction at best or delusional at worst. That said, data custody is something that we're really interested in and hearing a lot about, so worth considering. As I mentioned earlier, the array of solution components at play now continues to grow at an astounding pace. So how do you integrate and interoperate with that larger ecosystem? And lastly, with that explosion in solution components comes the need to make sense of it all. How do you govern data flows and understand the actual versus desired state of data jobs at any given point in time? So please consider this an open invitation to come talk shop with my colleagues and me. I'll be here all day today and most of tomorrow too. Once again, I'm Scott Truitt. Thanks again for listening. You can find me on the Twitters at SCT, my initials. You can find us around the corner here or on the web at heroku.com/data. Thank you so much.